Hello, welcome back to my channel. Okay, let's think about some weather hazards. So, when it comes to weather hazards, you need to be aware of global atmospheric circulation. Now, this is one of the aspects of geography that students find really hard because it feels very abstract. So, we're going to break it down step by step. The movement of the air across the Earth occurs in a specific pattern, and the whole system is driven by the equator, which is the hottest part of the Earth. So, air rises at the equator, leading to low pressure and rainfall. When the air from the equator reaches the edge of the atmosphere, it can't go any further, and so it travels to the north and to the south. It happens the same way in the northern hemisphere as it does in the south. As this air starts to become cold and fall, it creates high pressure and dry conditions at around 30 degrees north and south of the equator. Large cells of air are created in this way, and we call this the Hadley cell. Air again starts to rise about 60 degrees north and south and descends at around 90 degrees north and south. So we have the polar cell going on at the poles, we have the Hadley cell going on at the equator, and the one in the middle, which dictates the UK's weather, is what we call the Ferrel cell. Global atmospheric circulation creates winds across the planet and leads to areas of high rainfall, like the tropical rainforest, and areas of dry air, like the Sahara Desert. If you pick up the revision guide, there is something that will be very helpful for you in there, especially when it comes to the global atmospheric circulation model. It's got it all described for you there, and it will be a lot easier. So let's think about tropical storms. A tropical storm is a very powerful low pressure weather system which occurs as a result of strong winds and heavy rainfall. Tropical storms have different names depending on where they occur in the world. In the US and the Caribbean, we know them as hurricanes. In South Asia, they're known as cyclones. In East Asia, typhoons. And in Australia, they're known as willy-willies. And they all develop in the same way and have the same characteristics. So they all come under this umbrella term of tropical storms. So tropical storms are rotating, intense, low pressure systems, and they develop over warm tropical oceans above 26.5 degrees, between 5 and 30 degrees north and south of the equator. They never ever cross the equator. When winds converge or meet near the ocean surface, and where there is low vertical wind shear. So, the relationship between global atmospheric circulation and tropical storms. They are mostly related to the Hadley cell, the Coriolis effect, and the equatorial trade winds. So, if you've looked over the global atmospheric circulation at all, it's all there for you. I will also leave a video down below that I've done specifically on the global atmospheric circulation. And if you get access to that revision homepage, there's some from the Met Office as well that I will leave linked for you. So, the warm equatorial regions receive intense solar heating from the sun, raising the ocean temperatures. This warm, moist air rises, leading to an intense low pressure zone between the two Hadley cells, which is what we know as the Intertropical Convergence Zone, or the ITCZ. This generates thunderstorms, strong winds, intense rainfall, all at the surface. These are typical weather conditions at the rising arm of the Hadley cell. Dry air starts to descend, creating a high pressure zone at the surface. And this generates a high pressure gradient between intense low pressure and intense high pressure, generating the winds that form the tropical storm, moving from one to the other. If you think about it in terms of concentration, you've probably studied it in either chemistry or physics, and how if you've got an area of low concentration and an area of high concentration, when you remove that barrier, the dispersion happens very quickly. Again, that's what's going on here. So the trade winds move in a westerly direction from the equator, where the Coriolis effect starts to spin the air from 5 degrees north and south of the equator. If the effect is too weak at the equator, these start to move further north and south, and the spin is anti-clockwise in the northern hemisphere, but clockwise in the southern hemisphere, as they are low pressure systems. The greater the low pressure, the greater the winds, and the greater the spin, and the larger the tropical storm becomes. So let's think about the structure and features of tropical storms. In appearance, a tropical storm looks like a huge whirlpool, a gigantic mass of moist, revolving air. Tropical storms are between 482 to 644 kilometres wide and 6 to 8 kilometres high. They move forwards at speed of 16 to 24 miles an hour, or kilometres an hour I should say, and can move as fast as 65 kilometres an hour. The Coriolis force is caused by the rotation of the Earth, which causes the tropical storm to spin. The central part of the tropical storm is known as the eye. The eye is usually 32 to 48 kilometres across, and it's an area of lighter winds and no rain, but it has a lot of falling, descending air. They can find large towering cumulonimbus clouds around the eye, and these are caused by warm air condensing as it rises, which leads to heavy rainfall and wind speeds of up to 320 kilometres an hour. So, tropical storms develop between 5 and 30 degrees north and south of the equator. Because the easterly winds, they generally move westwards. The air above the warm ocean is heated, and once the ocean reaches at least 27 degrees, the warm air rises quickly, causing an area of very low pressure. As the air continues to rise quickly, it draws in more warm, moist air, rising up from the ocean, leading to strong winds. The rapidly rising warm air spirals, cools, condenses, and forms large cumulonimbus clouds. And these clouds form the eye wall of the storm, producing heavy rainfall. In the centre of the storm, however, cold air sinks, forming the eye of the storm, where conditions are calm and dry. So the impact of climate change on tropical storms. Climate change could lead to more locations being affected by tropical storms. Warmer seas could see the source area where the areas start to form extend further north and south of the equator. It's unclear whether climate change will increase or decrease the number of hurricanes, but climate models predict their intensity might increase. The following factors will play a part. So there's warmer ocean temperatures and higher sea levels. Wind speeds possibly will increase, and rainfall rates in these storms are projected to increase by about 20%. Sea level rise is also likely to make tropical storms more damaging, leading to more coastal flooding and more subsequent damage along coasts. Low-lying coastal communities where the population density is high and the income levels are low are most at risk. And there are also more people living in coastal communities in the future, which means that more people will be affected. Now, you will each study a different tropical storm, but if you study Typhoon Haiyan, there is a whole... Actually, you know what I'll do? Click on that link below, find the geography homepage, go into the challenge of natural hazards, and I will try and find some resources on a variety of different tropical storms for you, because there's no point me going through just one if you don't all do it anyway. And then if you would like to pick up the revision guide, it's all in there for you too. So, reducing the effect of tropical storms. There are several specialist tropical storm forecasting centres, such as the World National Hurricane Centre in Miami in Florida. The centre uses satellite images, various weather instruments and computer-based prediction systems to monitor, detect and track tropical storms. When a tropical storm affects a populated coastal areas, they are predicted and the centre issues warnings. You might remember this with Hurricane Helene not too long ago. Warnings also give the information to local authorities, which are likely to be placed in the storm's path, in order to make preparations for the protection of public safety. They are broadcast over the TV and radio, and warnings can be issued to people quickly and within enough time. They can also use reinforced aircraft fitted with various scientific instruments to fly through and over the tropical storms to collect data on it, which can be used to help to track and predict the path of a tropical storm. Okay, let's think about weather hazards within the UK. So an air mass is a large body of water, or large body of air I should say, with a similar temperature and moisture content throughout. Air masses can be small or they can be gigantic, covering for thousands of miles. Air masses over water are called maritime air masses, and they include a lot of evaporated moisture. The air masses that come from over land are called continental air masses, and they are much drier in the air. Depressions are areas of low pressure. They have warm and cold fronts, where the fronts are very warm and cold. The fronts are where warm and cold air meet. Along the fronts, you often get rainfall. Winds blow anti-clockwise from a westerly direction, all to do with the Coriolis effect. The wind forces can be gale force, and you can tell this when the isobars are close together. An occluded front is where the area of cold front catches up with the warmer front, pushing underneath it and forcing it upwards. Eventually, there will be no warm air left at the surface, and occlusions tend to wrap around the centre of a low pressure, with a narrow band of thick cloud which produces heavy rain. Depressions in the UK bring a lot of rainfall. You've probably heard of the word depression before in relation to mental health, feels low, so low pressure leading to rainfall. That's a helpful way to remember it. And then we have anticyclones, which are the opposite. These are an area of high pressure. They don't have fronts and they can bring stable weather conditions. In the summer, high pressure can bring hot and dry weather. However, in the winter, they can bring very cold weather, although not usually snow. The winds are often light and blow in a clockwise direction from the east. So our summer anticyclone weather conditions bring fine, calm days, long periods of sunshine, cloudless skies, heat waves. They may be colder during the nights due to no cloud cover. And after a few days, the air starts to feel a bit muggy, and we often then have a thunderstorm as a result. However, our winter anticyclone weather conditions bring dew and frost in the morning, fogs, cloudless skies, and cold nights due to no cloud cover. So I do hope this has been useful. Please do. Oh, if this is your first video with me, hi. There is a link down in the comments for you that you may or may not find useful. It's essentially a revision page. You'll be able to purchase revision guides there. There are already loads of free resources there, like past questions, there's recall questions. There's a way that if you would like to book a tutoring session with me, they are all down there if you would like. I think that's all you need to know for now. If your spec is not down below in the comments, there is an email down there. Please do drop me a message, and I am more than happy to get you the link for your specific revision homepage. But yeah, I do hope this has been useful. Please do share it with who you think might find it helpful, and I will see you in the future. Bye.